So welcome to the Earth and Atmosphere Laboratory. We are working on a groundwater unit. We will begin with the first part of the unit, today's lesson, evaluation of a groundwater aquifer in northern Arkansas. As we can see, this may look familiar. This is a topographic map where we have 10 active wells that do tap into this Swan Sandstone Aquifer. The name of the aquifer is the Swan Sandstone Aquifer. And right now on our map, there are labeled here 10 active wells. Here would be well 1, let's see, well 2, well 3. So you're going to have to look around. There's 4 and so on. 9 and there's 10. There's actually a new well here. This is going to be our job, is going to be to determine just how deep, okay, the farmer at location A must drill to reach the top of that sandstone, Swan Sandstone Aquifer here at this new location. They've got labeled here as well A, okay? So our job here is to, as geologists, is to tell the water well company just how far down they are going to have to drill. And the company, the drill company, does charge by the foot, so we would want to let our clients know as close as possible the number of feet that they will have to drill down to reach the top of that Swan Sandstone aquifer there, labeled there. So that's kind of our job, and there are several parts to this, so we'll take you sort of step by step to get to the completion of that. The total drill depth is what we're going to try to tell our clients here for their new well A. So on the second page of your handout, page 2, they do kind of have some steps here, what the first step is and second step and so on. But you've got a set of data here, sort of a data table that we were going to get completed. But you can see over here that that is the well number. So all those wells that were labeled on our topographic map are labeled here. Wells 1 through 10, remember those were the active wells. And then well A is where we're going to determine some information for the total drill depth. This little kind of parentheses here, you can see there's no value there. That's going to be our job, is to figure out what that value in feet are going to be. So over here, this column is the surface elevation. We can get those values by looking at the topographic map on page 1. We will follow along the contour lines. All of that practice that we have done in the previous topographic map unit will help us to determine what those surface elevation values are in feet for our active wells here, 1 through 10. So we'll be looking on that map to figure out what these surface elevations are. We just have to read our map. And as you noticed before, well A was also on the topographic map. So we can get these values just by looking at the topographic map and determining those elevations in feet, okay, above sea level. That's why they're calling it the surface elevation. Well, here in this second column, this is the total drill depth to the top of the Swan Sandstone. SS stands for sandstone. The aquifer, to the top of the aquifer, to be right at the water table there. And this is what they had determined previously, that they had to drill down to the total drill depth to get down to the top of that aquifer. Well, that's going to be our job for well A. Well, we need a little more information here. What we need are the subsea elevations of the Swan Sandstone to the top of that aquifer. Okay, subsea, meaning below sea level. If you remember on our topographic maps, all of those are, all the feet are indicated above that datum of sea level, right, as a datum. Normally sea level for our topographic maps as our datum. That's like our 0 line. And anything above that on the topographic map was those surface elevations. So we'll get those there from that map. But we're interested in the subsea elevation, so the below sea level, below our 0 line. We need those subsea elevations in order to study below the ground surface, right? That's where the aquifer is. Okay, and we can do a nice little calculation and calculate each of these, okay? And then we'll actually need to do a plotting and some contour lines to figure out this value for our new well, A. And we'll show you that step. But let's first kind of look at the idea of what we're going to be doing with these values once we get them. So I've kind of done a little drawing here that might help us to visualize this. Let me get that up real quick out of the way. Okay, so the idea is this will be for well 1. If we look at the topographic map, we've got a surface elevation that we can determine. We'll pop the map back under here in a second. So if you notice here, I've drawn a sea level line, which of course is 0 feet. That equals sea level. That's the datum that all of our topographic maps are based on. So many feet above sea level. Okay, so this is the surface elevation, it's called. Of course, that's the feet above sea level. There's our sea level line. That's our 0 feet. And that would be the surface elevation. And we can figure out that from our topographic map, that value in feet for well number 1. My example of my drawing is just well number 1. We can get that. The total drill depth, if you looked back on your data table on the second page here, okay, for well 1 that's the total drill depth, 1428. They gave us that value. That's why I have written this value here, total drill depth. That would include the surface elevation, so the feet above sea level, plus the feet below sea level. We call that the subsea elevation. So from the data table, we got that value that was given. That's the total drill depth. Okay, from the top surface elevation of our well to the top of the aquifer, subsea elevation. That's total, that's given, okay, for well 1. So in order to determine the feet below sea level, or the subsea elevation, you have to do a little subtraction problem, okay? You take your total drill depth minus the surface elevation, because we got that from our topographic map, no problem. Do a subtraction, and what's left over is the subsea elevation. So we can do a simple calculation and get that value. And so we'll be doing some of those. But let's take a look at our topographic map for well 1, right here. Well 1 is off over here, okay? The little dot is the location of the well, so they've just kind of put a circle around it, and then they've numbered it number 1. So there are lots of contour lines on here. There's this one's like a 350, okay, right there. Some of them are labeled, right? So we get an index contour every now and then. You remember that from our studies. So we should be able to figure out what our surface elevations are. Actually for each and every one of our wells, including our new well, A, over here. So let's look at the very first one, well 1, since that's what my drawing is of. And incidentally, I want you to make a little note here that line, that value right there, it says 342 feet. 342, right there where well 8 is. It kind of looks, because the 2 gets cut with a contour line, makes it look like 348. Well, that's a contour line there. So this actually is 342. So make yourself a note that well 8 is right there at 342. Kind of have a little benchmark value there. Okay. All right. So for well 1, if that one is 350, okay, and we can look at some other values and try to determine um, the value of the next one. And this contour interval is going by 10 feet. Okay, so we do have a 10-foot contour interval going in between each line. So if that one's 350, this one's 360, so the one that our dot is on for well 1 would be on 370 feet. So you see the idea. You're going to need to very closely look at all the little contour lines, the index contours to help you. Every now and then there's a benchmark. A lot of these do lie right on a line or very close to a contour line. If they're somewhere in between, then you'll have to estimate a value for them. But your goal will be to work through each of those and find what the contour interval value is, the contour elevation line is on for the surface elevations for each of these. Well, if we just looked at number 1, so I can finish out the little drawing there for number 1. That surface elevation is 370 feet. And I got that from this contour map, okay, this topographic map. So 370 feet, okay, is my well 1. Remember, we are working on well 1 here. From the data table, as you recall, that was 1428, the total drill depth from that center column. All right. So surface elevation would be 370. Okay. Total drill depth to the top of the aquifer, okay, that's the whole thing, that's given. Okay. So what is this value? Well, you do a simple calculation. Take your total drill depth, the 1428, minus the surface elevation. Well, whatever's left over then is going to be the subsea elevation. So when we do that, do your little calculation, we end up with 1058, okay, as our subsea elevation. So from sea level down to the top of the aquifer, the Swan Sandstone Aquifer, is 1,058 feet. Okay, so you'll be doing a little calculation like that. You'll be using the total drill depth given, subtracting the surface elevation that you find from your topographic map, and you'll determine that third set of data, that third column, the subsea elevation. Okay, so that's what we're going to work on. You'll need to be getting that filled out for each one, each well. So we determined that was 1058 over here. And basically I took the total, that should say total, okay, total drill depth, that's given, minus what we found from our topographic map, the surface elevation, so above sea level, so many feet. So do your subtraction, and you'll have your subsea elevation, okay, below sea level, the elevation, okay, below sea level. And you did that by subtracting those two, okay? So you'll do that. You'll repeat that. You'll find the value of the surface elevation for each of your wells, including well A. Okay. Now notice, well A does not have the total drill depth. That's our job. We're going to determine that, okay? So let's go ahead and get that completed. If you need to pause the video, do so, and go ahead and get those all worked out. Okay, of course we can't get this value or this value yet, but we can get all of the other values, including the surface elevation for well A. All right, so pause the video and take some time to do that. This is something you will do on the exam, so it's best to practice it. Okay, and then we'll return and we will show you the completed set of data for that. Okay, hopefully you've had a chance to go through and determine all of your values for your surface elevations. Now your numbers may vary slightly from mine, and that is fine, as long as it's just a few feet here or there, maybe 3 or 4 feet either side, because we did have to estimate on some of these values, and so that may change your values up just slightly, but I do still feel like if you're within 2-3 feet either side of these values, I think that you'll come out very close on these two endpoints that we're after here, our job as geologists here. So these are the values I came up with, and so you will want to check those. These are the surface elevations that you can get from your topographic map. And remember that well 8 was 342. I know it kind of looks like 348, but there's a contour line that was going through that 2 that made it look kind of like an 8. So all of that first column here, the surface elevation, those were found from the topographic map back on page 1. Okay, and you had to follow the lines around and really examine them. All of our good practice we got from our topographic map unit comes in handy here. Okay, so hopefully you did get something close to these values. All right, the next step was to take the total. You might add that to there. This is the total drilled depth to the top of the Swan sandstone from top to the bottom. Okay, top of the Swan sandstone there, like the total amount. Show that picture again. From the surface of the well, clear down to the top of the aquifer, so above and below sea level. That's what this center column is. It's the total drilled depth. And so those other wells had already been dug, and so this is what the total drill depth were for them. And so those values were given. And then you took the total drill depth, subtract off the surface elevation, and you got your subsea elevation of the Swan sandstone. So these are the values I was arriving at, okay, for each of those. Again, I'm covering these up because we're going to work on those. Those are part of our problem. So take a moment, make sure you double check, see, how close you got to those values, and they should be pretty close to these values here. These would be the ones that I've determined. Okay, just double check yours to see how you came out on that. And so you should have some pretty close values for these subsea elevations. Okay, and so once we've completed that, that's sort of our first step, is to be able to determine the surface elevations for each data point, including the new well, from the topographic map, get that entered on the data table, subtract the surface elevation, right, from the drilled depth. Okay, subtract that off. Subtract surface elevation off of the total drill depth, and record the information for your subsea elevation. So we've completed those couple steps in there. Next step is to plot the subsea elevations on the blank location map. Okay, and this will be on the next page. And we will contour the data points to produce a map that shows the structural configuration of the top of the aquifer in the subsurface. So I've put a star here, map these. These are the values that you'll want to be putting on the location map on the next page. So make yourself a note so that when you do this for the exam, that you remember you are plotting this column, not this one, not this one. You're going to plot these values from the subsea elevations. That's very important when you get on the exam, that you don't map the wrong column of data. So it's the subsea elevations that you're going to be plotting these this data on. Okay, so let's locate then our little location map that those values are going to go on. So this would be your page 3. Find that here. Okay, and you see here, this is your page 3, that we have those 10 wells. Okay, you have to hunt for them. There's 2, 3, and so on. Here's 4, 5. They're all on here. There's 10. And here's our new well A. Okay, subsea elevation. We don't have that value for A yet. The whole idea is to complete this structure map, this location map, by plotting out all of those subsea elevations. Okay, so data point here for well 1, our subsea elevation, back over here. The subsea elevation for well 1, right here, is 1058. So what you would do is draw in that value, 1058 for well A, and repeat that. What is it for well 2? 1080. So we'd write 1080 over here. So you get the idea. You're filling in the subsea elevation data. Okay, and do this for all of your wells. Okay, except of course well A, we don't have that value yet. We're going to determine that value by plotting this out, doing our contour lines on here. I'll show you that in a sec. And then determine the subsea elevation of well A so that we can fill that in on our data table. That will be the next step in actually getting the total drill depth. Okay, what our clients are wanting is that total drill depth in the end there. Okay, so take all of those, this column here, and fill in that information by each point for each well. Okay, you want each dot. Do that for wells 1 through 10. So if you want to pause the video, go ahead and pause, okay, and get all those values written in. Okay, so let's take a look here. See what we came up with. So you've filled in all your values. I've got some lines on here. These are my contour lines. But you filled in all the information from your data table, right, for each of the wells. And you put those values next to them. Okay. There's 9, 2, etc. Find all your wells. The next step, remember when we did the topographic map unit that I said you wouldn't be drawing contour lines, but you will on the next exam? Well, this is where you're going to be drawing some contour lines. And you can start on whichever side you want. But in looking at these values, we will draw these contour lines that you can see. Okay, they're kind of parallel, fairly parallel lines there. And you kind of want to examine your values, and you'll start to see, well, I've got some lower values over here. I've got a 1044, I've got a 1050s, in the 50s, in the 60s. Here I have something in the 70s. I've got an 80 there. I've got an 89 and a 90 here. Okay, and I've got an 1110 there and an 1120 here. So you're noticing that sort of the lower values are off over on the left side of your map, and the values get higher over to the right side of your map. So you can kind of get a feel for the layout of the elevations, the subsea elevations of our map, just by sort of examining those values across the map. And you can start on whichever side you would like to, but in drawing a contour line, these thankfully are pretty parallel, so we can kind of use a straight edge to help us with these. But we want to draw in contour lines with 10 feet contour intervals. Okay, so you would want several here. You'd want a 1040 line, a 1050, a 1060, 1070, 1080, 1090. 1100, 1110, and 1120 would be our lines that we would want to put in. Now, where are we going to put them? Okay. Well, here's a 1044. So the 1040 line can go pretty close to that 1044. Off up over here we have a 1050 something. Okay, so the next line that would go in, our 1050 would be about here, right? And then here would be our 1058. Okay, so a good place for that one. Here's a 1063, and it's pretty close to where our 1060 line would be. Okay, be a little closer to the 1063 than the 1058. So here we would go right in right about there for the 1060. You just make your best judgment on where those might go. So we had a 1063 and a 1078, so somewhat halfway in between there. I went ahead and put my 1070. Okay, well now here, luckily, we have a 1080 right there, so that one's going to go right through the point. It'll come fairly close to the 1078, but notice how the 1078 is going to be to the left of that 1080 because the larger values are to the right of the contour line. Okay, so you got to keep that in mind. Which value is higher, which value is lower when it comes to drawing the contour line. So that 1080, I'm going about like that with it. Okay, my 1090, well, we've got a point for well 6 right on the 1090. So there's a 1090, yeah, but there's a 1094 there and a 1089. So notice how we did that. Yeah, the 1090 is going to go right through it. The 1094 is a higher value, right? So it's going to be to the right of the contour line. 1089 is lower than 1090, so it'll go a little bit to the left of that line, okay? So I've lined those up about like that, okay? All right, then we've got a big break here from the 1090. We totally don't have anything that's for the 1100, but between a 1090 and 1110, okay, 1110, we've got a big space in here. We don't have any other values in here, so midway I've put the 1100. Okay, and then there's an exact line that we would go with the 10 or the 1110 line. Next contour line would be an 1120, and we've got an 1122 way over here, so fairly close to that. Remember, the larger value would go to the right of it, so we put it right about there, okay, for the 1020. And make sure you do label those with the values, so that's 1120, 1110, 1100, 1090, 1080, 1070, 1060, 1050, and the last one, 1040. Okay, so those are drawing in of contour lines, okay? Remember, we plotted the data for the subsea elevation, that third column to the right on our data table, and then we drew in our contour lines going by a 10-foot interval. Of course, you would be told what interval to use on the exam. Okay, so there's a great step in there. What we were able to determine by plotting out the subsea elevations and drawing our contour lines is we actually determined what the subsea elevation of well A would be by doing this method. And notice how well A, that dot there, is about halfway between the 1100 and the 1110 contour lines. And so I am estimating that we are at 1105 for the subsea elevation for well A. So we're almost there. We are almost there with our information that our clients need. So back to table 2, what we were able to determine by doing all of the plotting of the subsea elevations, right, was we determined the subsea elevation of well A. So we're almost there. That's the subsea elevation of well A. So now that we have that value, we can put it all together and actually be able to tell our clients how far they are going to have to drill, the total drill depth, to get to the top of the Swan Sandstone Aquifer for them. So our subsea elevation, so from sea level downward to the top of the aquifer, is 1,105 feet. We found from our topographic map what the surface elevation is. So how many feet above sea level? If we add these two values, okay, we add the surface elevation and the subsea elevation, just like my little picture I showed from before, okay, if you add these two here, right, you get the total drill depth. So if we add so many feet above sea level, and we figured out the subsea elevation, we've got everything we need to determine the total drill depth, okay, which is what our client wants to know. And so how we do that is, got that here for well A. So in our conclusion here from the completed structure map that we just did up there, the projected subsea elevation at point A can be determined to be 1,105 feet, right? And so what is the total drill depth for well A? Our surface elevation from our data, our topographic map, was 319 feet. The subsea elevation column, we did that here, we found it, 1,105. If you add those two values together, in this case we're adding them, that gives us the drill depth, the total drill depth to the top of the Swan Sandstone Aquifer. 1424 is that value. Okay, so you can fill that in on your data table. 1424, the total drill depth. Okay, and so you will want to be able to determine the total drill depth. So 1424 feet. If you tell your client that, and then they'll send out bids to the different drill companies, and they can charge anywhere $15 to maybe even $30 per foot. So we want to be as accurate as we can for our clients so they get good bids that come in for these nice competitive bids. So we want to make sure that you understand your steps for this. The first thing you did was look at your surface elevations from that topographic map, determine those elevations for all of the wells, including the new well. Okay, so we would look at this map, go back and find all the values. You'd have to, follow these little contour lines, all the values. They squiggle around quite a bit on this map. So that would be step one. Okay. Next thing, you fill in your data there. Next thing would be to calculate the subsea elevation of these. You're going to be given a total drill depth of wells 1 through 10 anyway. You would subtract. Take the total drill depth and subtract off the surface elevation. What's left over is the subsea elevation. So get all the values for all of those wells. Next step is to plot this information. And remember, it's this column, right? The subsea elevation column that you plot on your location map. Be on page 3 here. Right? So you put all those points, those data points, right? Then you contour them. You put in your contour lines. We use a 10-foot interval, and you'll use a 10-foot interval on the exam as well. Okay, and get those put in. Kind of examine the values and see where to start. You start on one side and work your way across. Kind of making sure that lower values are to the left, higher values are to the right of your contour lines, right? Okay. And put those in as best you can. And then determine what the new well value would be, okay, from this location map. And then you would have everything you need here to calculate your total drill depth of your new well. You'll have that subsea elevation. You will have the surface elevation. You add those two values and you get the total drill depth of the new well. Okay, and so that is your method that you will use in order to calculate the total drill depth to an aquifer, the top of an aquifer. And so that concludes the first part of our groundwater unit. So the evaluation of a groundwater aquifer here in northern Arkansas, the Swan Sandstone. So run that through. If you need to review the video, you can review it as many times as you need to. But if you do have any questions, make sure that you get with me. But that's that first portion, and we'll continue with the High Plains Aquifer in the next part of this unit. So thank you very much.